Well, this is what a composite function is. So yesterday we just add, subtracted, multiplied, divide. Yes?
Yep.
Today we are going to deal with composite functions. Another way of combining two functions is by doing the composition of them. And for instance, if I had f of x equals x squared and g of x equals x plus 1, the composition of f and g, we can say f of g of x or f compose g. That little circle right here, this right here means compose. It's open. You see it's open. It is bigger than a multiplication symbol. At this stage in the game, we're usually only using parentheses for multiplications, yes?
Yep.
So that means composition. So it's f composed with g. Normally we have f of x, yes?
Yeah.
And what if I put f of 6? What would you guys do? Put 6 for every x, correct?
Yeah.
Yep.
Well, now I put f of g of x. So that means I have to put g of x, the whole thing, in every time there's an x.
I remember doing that.
Yeah, you should have done it in Algebra 2 some. So, can I do g composed of f? Yes, I can do it in any order. So, I like to write it like this, but either form, the book will write both. So I have x squared, but my x is now what?
X plus 1.
X plus 1. So I have
So
x plus 1 squared. And then I can square that by foiling, correct?
Yeah.
And hopefully you'll get to the point where you can just do x squared, x plus 2x plus 1. And not have to write that all out. But if you do have to write that out, you know how to foil.
What's
Correct?
the arrow pointing to there?
The dot, the open circle.
What's that mean?
Compose. That it looks like fog, but it's compose. F composed of G. That means G goes into F. So if I wrote G compose F, what does that mean?
G goes into F.
Nope.
F goes into G.
F goes into G.
So it doesn't matter which way it goes?
So the second one goes into the first one.
The second one goes into the first one.
Oh, I thought you said F goes into G for the first.
No, F composed of G.
Mm.
And this is G composed of F. So that means you're putting the second one in. So let's do that. So in here, I have x plus 1, so my x is going to turn into what?
X squared.
X squared. So it's x squared plus 1.
You
And we're
can't-
done.
You can't go farther than that.
Yeah, and you're done.
Oh wow.
Wait,
So-
what?
I put in F into G. This is F, and I put it into the x. Now, are they the same? No. It is not commutative. Composition of functions is not commutative. You cannot do it in whatever order you want it. Now, there are times you get the same, and that's when they're inverses of each other, and that's our next section. But in general, you do not get the same. You can tie these in. I could have F of G of H of I of J of X.
What does that mean?
Okay, so it goes inside, it goes from the back, right? So I'm going to put J into what? I. And then my answer I would put into H. And my answer I would put into G.
Okay,
And my
that'd just be
answer I
a
would put
long
into...
problem.
That
It
would
wouldn't
be
really
Yeah.
be that hard.
Hey.
Am I ever doing that many?
I
No.
thought you said you were putting J in the I, but you wrote X into the
No, well, this whole thing. J of X. Okay? Now, we are doing 3. I think at most we do 3. But you're just going, it's just like any parenthesis, we go inside out, yes? So this is my furthest inside. So J into I, my answer into H, my answer into G, my answer into F. You notice I'm saying my answer. I need to simplify it. If I don't simplify it, would that get really confusing? Yes. But that can go as many times as you want it to go. At a certain point, you're just being ridiculous, I think. Okay, so f of x is x plus 2. G of x is 4 minus x squared. Find the following. So this is f composed of g, so which one's going into which one?
G goes into F.
G goes into f every time there's an x. There could be 6 x's, correct? And it would go in every single time. So x, what's x now?
2.
The whole, you said you just
4
told me
minus
G.
x squared.
So 4 minus x squared plus 2. Now, the parentheses do not have to be there, but I would start today by putting them there. Because if it's multiplication, we have to remember to distribute it, yes? If it's exponent, we have to remember to do that out. So if I put my parentheses there, I'm not going to forget it. Can I simplify this one further?
Yeah.
Yes, I
Or
can.
2 perfect squares. Or-
Well, I can just combine like terms, yes?
Oh yeah.
So then I have 6 minus x squared.
Yeah.
So what's happening on the next one? G composed of f.
You put in F
F
for
and
G.
You're putting f into g for the x. So I have 4 minus x plus 2 what? Squared. And then I have to do what with this? I have to square it. So I have 4 minus x squared plus 4x plus 4.
How do you get 4x?
Because if I FOIL that out, because it's x plus 2 times x plus 2. If I
Oh,
FOIL
okay.
that out, I'd have 2x and 2x. So now what?
They combine like
No, not yet.
You
Put
have
it
to
in
put the,
order.
you have to make everything negative.
I have to distribute my negative. See why those parentheses are important?
No.
If I didn't have those parentheses there, I'd just make the x negative, but everything in here is negative, correct? Or changing signs.
Yeah.
So now I have negative x squared minus 4x,
That's it. Because the other ones
and then
cancel
I
out.
have a positive 4 and a negative 4, so the other one would be 0. If I wanted to make it look better, could I factor out a negative x? Is it the same answer? Yes. If I asked you for the zeros now, you have to factor it, right? Set them both equal to 0. So there's things you can do it. But the main point of today is to know when I put G into F, F into G, or whatever they call them. They typically start at F and go down. F to K, J, but they could keep going. Okay, so what does this say to do?
Put F in for G and use -2 for x.
Right, so do F into G, and then
Solve
when I'm
that,
done,
and then
plug
fill
in
in 2
negative
for
2.
Can we just do that?
And we did this already, correct, right here?
Yeah, but we'll just put a -2 in for x.
Now we just take that, and we're going to put -2 in for x. So I have negative, -2, -2 plus 4.
So
Why do you
2 times
that makes no sense.
2
How?
would it be 4?
Just a second. This is my x now, yes?
Yeah.
So that is negative, and x is what?
-2.
-2. And there's an x, so what's it now? -2. So a -2, I get what? +2 times 2 is 4. Now, could I plug it in right here? Yeah?
Yeah, but you still
It would be -2 squared minus 4 times -2. So -2 squared is 4, and then it would be negative, and then -4 times -2 is +8, and I get what? 4. It doesn't matter where I plug it in, should I get the same answer. Now, yesterday we plugged it in at the beginning, yes? And then did it. Now here, if you want to plug it in at the beginning, you got it different, a little bit different. I would advise you not to do it, but you can. Okay, F into G, right? So that means I put -2 into F first. and then my answer into what? G. So if I put -2 into F, so F, a -2, would be -2 plus 2, which would be what? 0. Then I plug my 0 into G,
And that would be 4.
Oh.
and I would get 4 minus 0 squared, which would be 4.
I like that way better.
But you can't do that.
Why not?
Because you have to do the, you need to practice the composition, because to prove inverses, you have to do composition with variables. So you need to practice it so we can do inverses. So again, this visually shows you what happened, right? I put it into F, and then I put my answer into G. Now if I had that really long one again, and I had numbers, would it be pretty easy? Yep, I just go on the inside and keep going back. Questions? Okay, I want you to try these. We'll do one together, and then I'll let you do the second one. Okay, so F composed of G of S. What am I doing? We're putting G into F. Now, G is a trinomial. Does it matter what it looks like? No, I'm still doing exactly the same thing. So, F composed of G of X. So, 2 times what?
3 times x squared plus 2x minus 1.
Plus 1. So then what do I have to do?
2 times everything inside.
Okay, I have to multiply everything by 2. So I have 2x squared plus 4x, and then it'd be minus 2 plus 1, so -1. Bless you.
Wait, what happened to the plus 1 at the end?
You put
Because
it
this
in
is-
one at the end.
Minus 2, and then plus 1.
So you combine -2.
Oh,
Combine
silly
it.
goose me.
Without showing.
Okay? So now try G composed of F. So what are you going to put in? What?
You're gonna put
F is for
You're
3.
going to put F into G, and this one's going to be a little bit longer. Evan, can you see better today where I put the desk? Do you guys have enough of a head start that I can start? Nobody's screaming now. Got that? Okay.
How did you get the 2 in front of the 2x plus 1 on the second one?
There's a 2.
Oh, I missed that.
Get that?
I didn't get the second. Wait, I got 4x squared plus. How'd you get 2 4x's?
Because you foiled.
Because you're foiling. So you have.
I forget to foil.
Are you doing the big no-no? You
No.
cannot distribute into a quantity. Don't do that.
What does that mean?
She's taking this squared
Just squaring
and
every
just
side.
squaring each individual thing. It's a square is it's the multiplied by itself. Yes. She's just squaring the 2x and the 2 and the 1. Sorry. And stop that, Alex. You need to stand up. Cause your head's gonna like fall off your neck. Go like this.
So how'd you get never mind.
That's what I got.
Okay, so when we combine like terms, we should put 4x squared plus 8x plus 2.
That's what I got.
That's what you got.
Wait, where did the second I don't get why the 4x would still be squared.
Because you have to take 2x times 2x, which would be 4x squared. X times x is x squared.
So wait, when you take the 2x plus 1 squared, you get 4x squared plus 1.
No, you get 4x squared plus 4x plus 1. You have to FOIL these two.
Oh,
Or you hang a big no-no like me.
I guess.
Don't do that. I always think we should really do inversion therapy with that. I'm going to get you a rubber band, and every time you want to do that, you snap it. And then you're like, ooh, no, I can't do that.
Ooh.
Okay, now if I wanted to, what could I do with this to make it look prettier?
Factor it out.
Just factor out a what?
2.
2. And if I needed to try to factor, I could. But the factors of 2, I don't think any day are going to add to 4, are they?
Do you have to do that though?
No. The factors of 2 are any day going to equal 4, so you have to do the quadratic formula on that. So, which is always an option. Yep. Okay, so what's this say?
F
Put
into
F
F
into
and then
F,
2 in for
And
X.
then
So F into F.
Yep.
Okay, so try that.
For X.
This one's much easier than E. Just wait till you get like an X cubed.
Ooh.
Okay, so you should have what? 2 times 2x plus 1 plus 1. Everyone good there?
Yeah.
And then distribute your 2, right?
Yeah.
So you have 4x plus 3
Plus 3.
Plus.
because
Oh,
I have
2.
2 and I have 1. So now I need to plug in what?
2. Negative 2.
Negative 2. So 4 times negative 2 plus 3 is negative 5. Last time I checked.
yeah, I got it.
Okay, it's not too bad, right? Do I just have to make sure I follow my rules, distribute my negatives, make sure? Yes. Okay. So we just have to go through and make sure we're doing everything we need to do.
Yeah.
Yep.
Okay, guys, I think we're done.
I'm
That means you have
feeling this
work time
assignment.
today.
I'm feeling
I'm
this.
so glad that there isn't a
Yes, you are done.
What time?
Okay, guys, I'm still recording, so chill.
Sorry.
Okay, you can start writing your homework assignment down.